Hello and welcome student in this fourth lecture of this oscillation chapter. Now today we will proceeding the next part of the chapter. So in the previous lecture we have discussed about this point. The diagram is popping on your screen. In this article we have seen the three cases of that block. You can see the arrangement that the spring is attached to the rigid or fixed support and other end of the spring is attached to the block having sufficient amount of mass. This block is moving over the frictionless surface, means there is no friction will be there even if the block will be moving over that surface. So this will start when the block will towards the rightmost position. We will pull the block towards the rightmost position, then we will leave that block from its force. Now while we are pushing the block towards the right, we are just preparing for some amount of restoring force in the spring, and we will just leave that block from the rightmost side or the rightmost position, having it will possess the displacement from its equilibrium position at a length of x, means x will be the displacement of that block we have made from its equilibrium position. Then we will leave that block, means we will stop applying force over that block. Then what will happen, that block will try to come suddenly towards the leftmost position, means it will try to move towards the fixed support of the spring, means at the left side. Now while the block will be moving towards the left side, the definite positions the block will attain. The first one, the position which we are going to consider, is the equilibrium position that block will attain. Then after that equilibrium position, the block will move towards the left again, so it will cause the displacement at the left side from its equilibrium position, and that displacement will be x, say minus x, as it is left side from the equilibrium position. So the displacement of the block from the toward the right side from the equilibrium position will be considered as the plus x, and the displacement of the block towards the left side from its equilibrium position will be considered as the minus x. So these are two displacement we have considered as a plus and the minus. So the block will move towards the left and will cause the minus x displacement. Now the restoring force in the both the cases, at the right side of the equilibrium position and at the left side of the equilibrium position, will be F is equal to minus k into x. So after that we have considered these three cases. Now we know that the F is equal to minus k into x, and according to the Newton's second law, which gives the definition of force, which is mass into acceleration. So this will be the definition of force, and both are forces when we equating, then we will get ma will be equal to minus k into x. So if you want to calculate the term of acceleration, then it will be minus k upon m into x. So this will be our next equation. Now we have to calculate first the velocity. So the velocity is nothing but the displacement caused by that particle in definite time or in per unit time. That will be our velocity. And we know that the acceleration is the rate of change of velocity with respect to the time. So if you want the acceleration, then we have to differentiate the value of v two times. Then we will get acceleration is equal to d square x upon dt square. Now we will put this value of acceleration, this value of a, into above equation, and it will become the ma is equal to minus kx will become m into d square x upon dt square will be equal to minus kx. Now we will rearrange the terms, that the d square x upon dt square plus k upon m into x will be equal to 0. So we have just rearranged that the minus k will come at this side of the equal sign, so it will become the plus k by m into x will be equal to 0. Now the most important term is we have to substitute the value of k by m as omega square, and the omega square is nothing but the angular frequency. Omega is nothing but the angular frequency. So don't forget, student, the omega is the angular frequency which we have to use frequently in this topic for the different types of derivations. So keep in mind this term. Hence the k by m is equal to omega square. We will put this value of k by m into the equation, then we will get the d square x upon dt square. Omega square plus omega square into x will be equal to 0. What will be the final expression? It will be d square x upon dt square plus omega square x will be equal to 0. So after the putting the value of k by m, this is the expression we have obtained of the SHM, means differential equation for the SHM. So you have to use this while solving the problems, and if there will be the question of to derive, then you will have to derive as I have given you the tricks in the previous video. You can refer that one. Now we will see the next part of this chapter. For further derivation, we will be requiring this diagram. We have to take help of this diagram, so it will be keep on popping on your screen. You can take in refer for your understanding. So we will see the next part with the help of this diagram, that is the derivation for the acceleration, velocity and the displacement. We will see now. Now for that next derivation, we will take the reference for the first one. As we have derived that the d square x upon dt square plus omega square into x is equal to 0, we have already derived the differential equation for the SHM. Now we will just make some arrangement that the d square x upon dt square is equal to minus omega square, means we are just going to take the omega square into this side of the equality sign, so it will become the minus omega square. Now we have the value a is equal to d square x upon dt square is the acceleration of the particle performing SHM, that is simple harmonic motion. Now a will be means the acceleration may be also written as you can see here minus omega square x, because we have take that term at this side of the equality sign, and the value and the d square x upon dt square is equal to minus omega square. Now this is the expression for the acceleration in terms of displacement x. Now from the above equation we can write that d square x upon dt square is equal to minus omega square x, as we have derived. Now we will just we will take one term common, that is d by dt into dx by dt is equal to minus omega square into x. Now what mean by the dx by dt? Dx by dt means it is the displacement with respect to the time, so it will be velocity, and the velocity may be also written as dv by dt. Okay, so these two some terms in combine may be written as dv by dt, which is equal to minus omega square x. So dv by this dv by dt term may be also written as dv by dx into dx by dt. So this dv by dt we have written as in the two splits the term. First one is dv by dx dot dx by dt. So we have given the value of dv by dt in terms of two terms, so which will be equal to minus omega square x. Now this dv by dx, we know that it is the velocity, so v into dv by dx is equal to minus omega square x. So we know that the v into dv by dx is v dv. Okay, so small change in velocity, it is v dv, which will be equal to minus omega square x into dx, means dx is here in denominator, so in at this side of equality sign it will come into the numerator, so it will be in two term. Now we will just integrate this term. We will get integrating both the sides, we get integration of v dv is equal to integration of minus omega square x dx. So as we know that the minus omega square is the common term, so this will come at this side of the integration. So we can write as integration of v dv is equal to minus omega square into integration of x dx. Now we know the value of, if we integrate the v dv, you know that it will be v square by 2, which will be equal to minus omega square will be as it is into x dx. The integration of x dx will be x square by 2 plus c. So students, c is the constant here. Now students, c is the constant and it is the constant of integration. Now let a be the maximum displacement, means it is not, displacement is nothing but the amplitude of the particle in SHM. Now when the particle is at the extreme position, means the block will be at the extreme position, means at the rightmost position, then the velocity is 0. Means as you can take into consideration that the block M is at the rightmost extreme position, so there will not be further velocity exist in that block. So the velocity will be 0 at that position of the block. Now thus x will be plus minus a. Okay, x will be written as the plus minus a, means x will be the displacement which is plus minus a, and the velocity will be 0. Thus we can rearrange the equation that it will become 0 is equal to omega square into a square upon 2 plus c. Means you can see here students, as we know that the v is equal to 0, so whole term of v square by 2 will become 0, and the remaining term will be omega square into a square upon 2 plus c. So now here you can see the next step, that the c will be calculated as, means the constant of integration will be plus omega square into a square by 2. Now the value of c we can use for further calculation in this previous equation, that the equation will become the v square upon 2 is equal to minus omega square x square upon 2 plus value of c is omega square into a square by 2 we have put here in this equation. Now the terms in the denominator are 2 2 2, so it will be get cancelled. So and you can see the omega square is the common term in the both the terms which are in either side of the plus sign, so we can take in common. The next step will become v square is equal to omega square into bracket a square minus x square. So this will be the term. I will explain you one more time the next step, that as the 2 is at the denominator of the each term, so it will be get cancelled. Now the next step we have followed is the omega square is the common term in the both the terms which are on either side of the plus, so it will be in common, and as the first term, that is minus omega square into x square by 2 is having the negative sign, you can see. So this negative sign we just applying into the bracket, so it will become a square minus x square. So the whole term will become v square is equal to omega square into bracket a square minus x square. Now if we take the square root of the v, so it will be square root of the v square, it will become the v, so it will be the square root of the omega square, it will become the omega only. So v is equal to plus minus omega into square root of a square minus x square. So but students, always keep in mind, when there is a square root of any one positive term, so there is the possibility of plus and minus term, because as they will make the square of 2 only plus 2, it is always 4, and if you make the square of minus 2, it is also 4. Then we can say the square root of the omega square, it is plus minus omega. So the final expression will be v is equal to plus minus omega into square root a square minus x square will be the expression for the velocity of a particle performing linear SHM in terms of displacement x. Okay, so this is the entire derivation we have learned about the velocity. We have till now we have calculated the velocity and the acceleration. Okay, students, we have calculated the acceleration, the expression for the acceleration which is for the particle performing SHM, and the velocity for the particle performing linear SHM. Okay, so these two expressions we have learn here. Now the next part of this chapter we will learn in the next video. Thank you so much, students.